Hello friends, welcome to Pandul Hub, and here we are back with the part 2 of Java interview questions. If you haven't seen the previous part, please do check my channel for the previous parts of Java interview questions. So let's move into the part 2 now. So the question is, how would you differentiate between a string buffer, and a string builder? So considering the storage area, in the string pool serves as the storage area. But for string builder and string buffer, heap memory is the storage area. So we are aware that in the Java, as the string, the famous word or the keyword is immutable. Since the string is immutable, we already know that all the strings are stored in the string pools. Whereas the string builder and string buffer, which are mutable, they get stored in the heap memory. So going on with mutability now, a string is immutable, whereas both the string builder and string buffer are mutable. As I already mentioned, this we all know. Going with efficiency, it is quite slow to work with a string. However, string builder is the fastest in performing operations. The speed of a string buffer is more than a string and less than a string builder because it is synchronized. So here what does the efficiency mean is how fast it is. So it says the string is quite slow. What does that mean is for every string object that we create, there is a unique entry that gets created in the string pool. So when we try to change the string, since it is immutable, instead of modifying the original string, what it does is it creates a new string in the string pool and just updates the reference of this created string object. So all this process is going to take little time. So what does this say is this string is going to take little more time than the other string buffer and the string builder. So coming to string builder, which is mutable. So it is fastest in performing operations. So what does that mean is this string builder, which is mutable, that is when you try to modify a string builder object, it modifies the original object. So it's not like a string where it creates an another in the string pool and just updates the reference. But here the original string builder object itself is updated on modification. So it's very faster. You don't have an overhead of creating a new one in a string pool or pointing the reference and all those things. You don't have that stuff here in the string builder since they are getting stored in the heap memory. And going with string buffer, it says that it is faster than the string, but it is little slower than the string builder. So that implies is the string buffer is synchronized. That is, we have a thread safety mechanism implemented inside the string buffer. So it is little faster than the string, but rather it is little slower than the string builder because string builder is not synchronized. So for example here, so appending a character is fastest in string builder and very slow in string because a new memory is required for the new string with appended character. So this is what I mentioned earlier. So going with thread safe, in threaded environment, string builder and string buffer are used whereas a string is not used. So as I already mentioned, in threaded environment, string builder and string buffer are used whereas string is not used. So string builder is suitable for an environment with a single thread and a string buffer is suitable for multiple threads as it is synchronized. So I hope the sentence is clear for you as it says its meaning. So going with the syntax, so this is syntax for a string and here is the syntax for the string, the second syntax, and the third one represents the string buffer and the fourth represents a string builder. So going on with the next question, which among string or string buffer is preferred when lot of updates required to the data? So string buffer is mutable and dynamic in nature, whereas string is immutable. So this is a universal fact which everyone knows, where string is immutable, whereas a string buffer is mutable. So every updation and modification of string creates a new string, thereby overloading the string pool with unnecessary objects. So what does this mean is, for example, you're creating a string object, say object 1 and you're assigning some value to it. So what happens is this the JDK, what does that do is it creates an entry in a string pool for the object one. So when you try to modify the object one to a different value, it doesn't update the string object. So instead what it will do is it will create a new entry in a string pool with the new value and it will get pointed to the string object. So if you keep on updating the string object, for every updation, there is an entry that gets created in a string pool. So here the string pool gets unnecessary objects. So for example, you are modifying an object 5 times. So in that case, you have 5 objects in the string pool, but only the last one, the fifth, is going to point to the string object. So all the other 4 objects which lie in a string pool are unnecessary. So it is like an overloading of the string pool. We don't know who will use it or who is using it or is someone pointing to it. So all those stuff. So hence in the case of lot of updates, it is always preferred to use string buffer as it will reduce the overhead of the creation of multiple string objects in the string pool. So you feel that there is going to be a lot of updates to that string. So in that case, it's better to go with a string buffer as as you can reduce the overhead of the string pool. So we can use string builder also, which will be faster that string when there are a lot of updates required to data. So in addition to string buffer, you can also use string builder, which is not synchronized if you're going to have a lot of updates on the string. So the next question is, why is the character array preferred over string for storing confidential information? So in Java, a string is basically immutable, that is, it cannot be modified. As said, this is said many times and it's the known fact. So after its declaration, it continues to stay in the string pool as long as it is not removed in the form of garbage. In other words, a string resides in the heap section of the memory for an unregulated and unspecified time interval after string value processing is executed. So what does this statement mean is, as I previously mentioned, if you are going to have a string object and you're modifying it multiple times, for example, 5 to 6 times, so there will be 6 objects in a string pool where one is going to point to the string object and the other 5 are going to be unnecessary objects that reside in the string pool. So we don't know who is pointing to it or whether they are in use or they need to be garbage collected or is there any reference to some other string object for all those 5 objects in the string pool. So we don't have such information. So in that case, we are not aware of how much time or for how much specific time those objects are going to lie in a string pool or whether they are ready to be garbage collected. So all these informations are unaware to a user. And if you are going to have a string for a for storing the confidential information, and for example, you're storing a password in a string, and so in that case an object gets created in a string pool and you're going to change your password and there is another object that gets created in the string pool. So in that case there are chances that someone may hack or they can take the extract or they can extract the vital data of that password from the string pool. So as a result, what they say is vital information can be stolen for pursuing harmful activities by hackers if a memory dump is illegally accessed by them. So if this memory dump where we have passwords stored as objects in a string pool, so that memory dump can be used to get the vital information. So such risks can be eliminated by using mutable objects or structures like character arrays for storing any variable. So what do they see is, instead of going for strings, if we go with character arrays, since they are mutable objects and they don't get stored in a string pool, it will be safe for us because once they are not used, they'll be garbage collected. See, after the work of the character array variable is done, the variable can be configured to blank at the same instant. So consequently, it helps in saving heap memory and also gives no chance to the hackers to extract vital data. So to say in simple words, if you're going for character array over a string for confidential information, it will be very useful and it's the right way as I say, because once the character array is not in use, that will be garbage collected clearing the heap memory. Whereas storing in string, it creates additional objects in a string pool, making it available for other users where they can access it illegally. So the next question is, what is the difference between the throw and throws keyword in Java? So the throw keyword is used to manually throw the exception to the calling method. So this throw represents it is added. it is added inside a function so that it will explicitly throw an exception. The throws keyword is used in the function definition to inform the calling method that this method throws the exception. So what does throw say is it is added to the definition of the function. That is, it is added during the function definition. So it just represents, that is, all the types of exceptions or all the exceptions that this method will throw or added or appended next to the throws keyword. So for example, in this example, whatever I've shown here, so here is the throws keyword. This throws keyword represents this method function has the throws keyword, and it represents it is going to throw arithmetic exception if in case it occurs. So inside this function, you're going to see a throw keyword which throws a new arithmetic exception explicitly. So here, if this if condition is satisfied, I am throwing an exception explicitly so that it can be catched. So here in the above snippet, the method test exception divide throws an exception. So if the main method is calling it, that is, if the main method is calling this method, then it must have handled the exception. Otherwise, the main method can also the throw exception to JVM. So if you have a function definition which includes the throws keyword with some kinds of exceptions, then the method, here it is a main method, which calls that function has to handle the exception there. So if this method throws an arithmetic exception, in that case, the main method is going to catch it and it's going to handle the exception based on the exception it receives. So the next is what is serialization in Java. So serialization is a mechanism in Java where an object can be represented as a sequence of bytes that includes the object's data as well as information about the object's type and the types of data stored in the object. So basically what it says is you have a class objects. So those objects, they are just converting into a sequence of bytes. That process is called as serialization. So object in sense it includes what are all the parameters that includes about the object, like the object's type and the data that it is stored in the object. So all those things, all those data are converted into a sequence of bytes so that they can be stored in a file or somewhere like that. So after a serialized object has been written into a file, it can be read from the file and deserialized, that is the type of information and bytes that represent the object and its data can be used to recreate the object in memory. So what does this say is, so I said the object is being serialized into a file. So after the object is serialized, for deserializing, how does that happen? So during serialization process, object in sense it considers what type of object it is and what are all the types of data stored in the object. So based on those information, the same data is being deserialized and that object is being restored in the form where it was there. So the entire process is JVM independent, meaning an object can be serialized on one platform and deserialized on an entirely different platform. So it is JVM independent in sense it is platform independent. So the classes which help us in serialization are the classes object input stream and object output stream, or high level streams that contain the methods for serializing and deserializing an object. Okay, so the object output stream class contains many write methods for writing various data types, but one method in particular stands out as the write object method, which takes the parameter as object. And the object input stream class contains the following method for deserializing an object, that is the read object. So here when you see while reading, for example, you have an employee object and you are just serializing it. So when you deserialize it, you don't get an employee object. It is a generic object where we need to typecast it to appropriate data type that we need. So this says is this method retrieves the next object out of the stream and deserializes it. The return value is object. So you will need to cast it to its appropriate data type. Okay. So what is the difference between abstract class and interface? So going with abstract class and interface, an abstract class can have abstract and non-abstract methods. Okay. So interface can have only abstract methods. Since Java 8, it can have default and static methods too. So we know what are abstract classes. So abstract class is nothing but a class which cannot be instantiated. So this abstract class should include some abstract and non-abstract methods. So abstract class is the one which cannot be instantiated, whereas abstract methods are the one which doesn't have any definition. Okay. So coming to interfaces, interfaces have only abstract methods. They don't have any non-abstract methods. But from Java 8, interfaces support default and static methods. Abstract class doesn't support multiple inheritance. Interface supports multiple inheritance. So abstract class can have final, non-final, static and non-static variables. Interface has only static and final variables. We already know it, right? So abstract class can provide the implementation of an interface. Interface cannot provide the implementation of abstract class. The abstract keyword is used to declare abstract class. The interface keyword is used to declare the interface. This is obvious. An interface class can extend another Java class and implement multiple Java interfaces. An interface can extend another Java interface only. So this is the basic thing, right? A class can extend another Java class and it can implement any number of interfaces, whereas an interface can extend only a interface. An abstract class can be extended using keywords extends. An interface can be implemented using keyword implements. So this is also obvious, the extends and the implements keyword. A Java abstract class can have class members like private, protected, etc. Members of Java interface are public by default. So since this is a class, which is an abstract class, so this includes abstract and non-abstract methods. So non-abstract methods includes they can have any class scope like private, protected, etc. Whereas interface, we already know that it is a it is a it is a pure abstract class kind of thing. Like it is an interface only interface having only abstract methods. So since it has only the abstract methods where they don't have the definition, it is the need for us to provide a definition for the interface for the implementing classes of the interface. So all the classes of the interface which implement this interface are going to give a definition for that methods. So by default they are public. So here is an example of an abstract class like public abstract class shape. Here the abstract method you're going to have, and here is the interface interface declaration. So you're going to have a public method called draw. So the next one, what is the difference between comparable and comparator interfaces? So comparable and comparator interfaces, they are basically used to provide a sorting sequence kind of thing. So comparable provides a single sorting sequence. In other words, we can sort the collection on the basis of a single element such as ID, name, and price. So this comparable interfaces, so both are used in the case of collection to sort the collections. For example, you have a employee class, so you can use this comparable and comparator interfaces, and you can have your own logic, sorting logic. So if you have fields like salary, ID, name, an address, um, any department or anything, you can just create your own sorting sequence using any of these fields using these interfaces. So considering comparable, it provides only single sorting sequence, whereas comparator provides multiple sorting sequences. That is, you can use multiple fields of the class to create sorting sequences. Comparable affects the original class, that is the actual class is modified. So if you want to use a comparable interface, you are going to create or you are going to implement that in the original class. For example, you have an employee class, then you have to implement this comparable interface in the same class, and you're going to write that and write the sorting sequence in the same employee class. Whereas in the case of comparator, comparator doesn't affect the original class. That is, the actual class is not modified. This implies that you don't need to write this comparator or the sorting sequence logic in your employee class. You can have a separate class for the comparator, and you can write all your sorting sequences there, and you can use this comparator object for in the case of comparison for the employee class. So here you don't need to write any sorting sequence code, any single line relating to sorting in the employee class. Whereas if you use comparable, you're going to write the logic inside your employee class. Comparable provides compare2 method to sort the elements. Comparator provides compare method to sort the sequences. So here it is compare2. So if it's comparable, it's compare2, and if it's comparator, it's compare method. Comparable is present in java.lang package, whereas comparator is present in the Java util package. So we can sort the list elements of comparable type by collection.sort of list method, and we can sort the elements of comparator type by collection.sort of list comma comparator method. Okay, so the next question, what is volatile keyword in Java? The volatile keyword does not catch the value of the variable and always read the variable from the main memory. So if you are going to create a variable with a volatile keyword, then every time when the value of the variable is read, it is read only from the main memory and not from the individual caches. Okay. The volatile keyword cannot be used with classes or methods. However, it is used with variables, either primitive variable types or objects. So this keyword is only applicable to the primitive variable types or objects, but they cannot be used with the classes or methods. Volatile keyword always uses main memory for variable values, so they can be used to modify the value of a variable by different threads. So what does this line mean? So for example, you're having a variable where a thread is going to access it. So you know what is thread local. So thread local is nothing but every thread. So every thread, when it is accessing some objects or variables, it the variables and the objects that it is accessing, it has a local copy of it of it inside, which is called a thread local. So thread 1 is going to have its own copy, thread 2 is going to have its own copy, and so. But when you are working with the volatile keywords, every time when the thread reads the value of that variable, instead of taking the local catch, or it's from the thread local or from the what to say, you have a block of code where it has the instead of taking the variable where it has scope, so out of the scope, it doesn't matter whether it's inside a method or a class or a static block or whatever it is, that scope doesn't come into picture. If it's a volatile, then all the threads accessing the volatile variable values, they read only from the main memory directly, instead of using their own copies or whatever the scope they are in. So that is what this volatile keyword says. So this makes the classes thread safe, where multiple threads can use a method and instance of the classes at the same time without any problem. So if you're going with volatile, so every time when a thread is going to read it, it is going to read from the main memory and it is going to write in the main memory. So there is no issue where there is a consistency problem, because every thread is going to read from single place and it's going to write from a single place. So it makes sure, or it provides a thread safety for all the classes when multiple threads are accessing the variables which are volatile. Then what is transient? Serialization is used to convert an object into a stream of bytes. So we have already seen this. That is serialization, and since it is converting the object into a stream of bytes, after which we can deserialize it and convert it to, or cast it to the object that we need. The byte stream consists of the data of the instance as well as the type of data stored in that instance. So this also I've already told you, that is when it is converting the object into a stream, that stream includes what information? It includes the information of the data, what type of data it is, and what is the data that the object is consisting of. So deserialization performs exactly opposite and converts the byte sequence into original object data. So this is also we are sure that the deserialization performs the exactly opposite job of serialization. That is, it converts the stream of byte which we have stored into the original object. So during the serialization, when we do not want an object to be serialized, we can use a transient keyword. So if you don't want a variable or an object to be serialized, then you go with this transient keyword. So using the transient keyword, we can restrict the serialization of attributes in a class. So this is straightforward. So for example, if a program accepts a user login details and password, but we don't want to store the original password in the file, so here we can use transient keyword, and when JVM reads the transient keyword, it ignores the original value of the object and instead stores the default value of the object. So here we have an employee class where it has an ID, name and a password. So this password which I am declaring it to be transient. So when this object is being serialized, this field will not be considered as it is a transient variable. Instead, a default value of this object will be stored, skipping this attribute from this class object. So thank you everyone. Thanks for watching this. Hope this helped you. Please do subscribe to Pandol Hub channel and do like, share. If you have any comments, please mention those in the comment section. Thank you so much for watching it, and please do watch my other parts if you are looking for more Java questions. Thank you.